Good day everybody, my name is Johan Gunnarsson and today I will show you some efficient ways to check your model in HyperMesh. Some of the tools are new for HyperMesh 13 version and some of them have been available already since several versions. All of them are very useful tools when it comes to checking the quality of your FE model. Okay, let's start and have a look on the outline of this webinar. First, I will show you some mesh quality tools for 2D meshes. Auto-meshing tools often produce very high quality meshes, but sometimes it requires some manual work. And in HyperMesh we have several tools which help you to do this. And then I will go through the comparison tool which is new for the HyperMesh 13 version, and with this tool you can perform a comparison between two models or two selections of entities, which is very useful when you, for example, want to find geometrical differences between two models. And then I will show you the model checker browser, which can help you to avoid errors in your simulations by performing solver checks in HyperMesh before you start the simulations. During the presentation I will also switch to HyperMesh and show you live how the tools looks like and how to use them. Alright, first up is the mesh quality tools and the quality view, which is a permanent visualization mode that HyperMesh displays when you select by element quality on the visualization toolbar. And you use this to investigate specific element criteria, resolve all criteria violations at one time, or evaluate the overall quality of your 2D mesh. HyperMesh displays the multiple criteria legend by default. Here you can see it on the left picture here, and the fail values are defined in the current 2D element criteria settings, and by right-clicking you can change this if you right-click on the legend. The different element criteria can easily be reviewed with the use of the color coding, so each criteria has a unique color, and if an element in your mesh is failing the threshold value for this criteria, then this element is displayed with this color. And by selecting any of the criteria in the legend, you can investigate this criteria in more detail. A single criteria specific legend appears, and the colors now in the sliding window there reflects how good the elements adhere to this specific criteria. And for example, in the right window here, you can see how the Jacobian is, how the elements adhere to the Jacobian criteria. Another tool is the quality report. And the quality report tool creates an HTML report of the mesh quality and can be generated for either one model or multiple models simultaneously. After launching the tool, you're requested to choose a criteria file and the models which you want the report to cover. And the tool then creates first a single summary page which gives you a brief overview of several key metrics for all the selected models, and this page then links to other pages for each model which contains more detailed information on how the elements adhere to the different criteria. All the elements are divided into different categories: ideal, good, worn, fail, and worst categories, and you see statistics how many of these elements are in respective category. The quality index is also displayed. I will talk more about the quality index on the next slide, and as well you have links to the model that you're looking at as well as the criteria file. The quality index, or the quality, is found in the quality index panel, and this is used to create or calculate a single value which represents the quality of your complete mesh. And when you open the quality index panel, HyperMesh changes the color of the mesh according to how well the elements adhere to the criteria and the quality index. The quality index is a function of 12 criteria with user-defined weight factors. HyperMesh assigns a penalty value for each element, and all this means basically that the higher quality index you have, the worse is the quality of your mesh. So what you want is to have a low quality index, and for this example we see the quality index here, which is very high, and to have a good mesh you want a quality index that is close to 0. In the panel you have all the criteria and the fail values and the thresholds here on the left side. The criteria are divided into 3 pages, and on the right side you have more information on the number of failed elements, the quality index, and also a slide bar which you can use to change the thresholds for all criteria at the same time. Here you can see all the 3 pages with the different criteria. The criteria you can check or uncheck to make them active or not, and you can change the thresholds for the criteria. Page 3 contains some options, and you can, for example, edit the criteria file you're using, or you can create a summary file. So far, all the tools I showed you only helps you finding the bad elements, but very importantly is also to have tools to correct your elements. And this we find here on the right side under cleanup tools. And cleanup tools you use to change the placement of nodes to locally improve the quality of the mesh. Some of them are automatics and some of them require some manual work. The 5 tools in the right column are new for the 13 version. Also for HyperMesh, new for HyperMesh 13 is the element patching tool here. I think the easiest way to show you how the tools work is when I do a live demo, so therefore I will switch to HyperMesh now and show you how the tools work. Okay, first I will show you the quality view, which you find under the visualization toolbar here. And by changing to by element quality, the view changes, and the elements with bad quality are displayed in a color depending on which criteria that they do not adhere to. And if you want to, for example, look at the warp edge in more detail, you can simply left click on it, and the element that fails the warp edge criteria are now displayed, and you have a slider bar where you can change the threshold values. Then the quality report you find under mesh, check, elements, and quality report. You can either do it for just the current model, or you can select multiple models, and I will select multiple models. First you have to select a folder where the results should be saved. Then you select your models that you want to create a report for. And finally you select the criteria file. And the quality report is generated. So first, as I showed you before, you see a summary page with the different models that you have created a report for. And by clicking on any of these, it brings you to the more detailed view with much more statistics over how the elements adhere to the different criteria. And yeah, also here you have the link to your model and a link to your criteria file. Okay, that was the quality report. Now the quality index panel, I will first open a new model here. Okay, the quality index panel you find under Mesh, check elements quality index, or you can go to 2D and click on quality index here. Okay, this view, as you saw in the PowerPoint before, you see elements which have a high quality index are marked with different colors here, depending on how bad the quality is. Here you have the 3 different pages with the criteria and some settings, but I will go directly to the cleanup tools, which I think is more interesting. The first tool I want to show you is the place node. The place node tool allows you to move a node either normal to the surface like here, or along the surface like this. Modify hole and washer is a tool to change either the radius of a hole or the angle. You can rotate a hole with an angle. You can do this simultaneously with checking this radial and angular, and you can also rotate along the circumferential. So let's have a look on the radial. Then I just click on a node here and I can change the radius of the hole. With angular, I can rotate the hole, and for example, like doing like this, we see directly that the mesh looks much better. And all the time when I fix my mesh now, you can have a look on the quality index, which will get close to 0 when I fixed all the elements. Radial and angular at the same time, yeah, then you can change it at the same time. And circumferential is a little bit different than angular. I can show you with this one. If I would use angular for this a bit oval hole, the complete hole will be rotated, and this is not what we want for this case. What we want is to just move the nodes along the circumferential, and by clicking circumferential here, the nodes, you see the difference? They're just following the circumference of the slot here. Then there's also options to have an mathematical remesh of the a number of layers around the hole if you want that. The next tool is swap edge. The swap edge, we can change how 2 nodes are connected. So for example, this edge, by simply left-clicking, this edge is swapped, and the element looks much better. Node and element optimize, they are, node optimize works like the place nodes, but that's with the difference that in this case you just click on a node and HyperMesh automatically calculates the optimum position for that node. So I show you some different elements here. Just by clicking on the nodes, you improve the quality of the elements. And element optimize works just the same way. You just click instead directly on an element, and the nodes for the elements are moved in order to improve the quality of those elements. The next tool I want to show you is the split quad element. We have here 3 quads with bad warpage, and a way to fix this is to split them into trias, and with this tool you simply click on them and the elements are divided into trias. And similarly, we have the combined tree elements, where you can take 2 tree elements and combine them into a quad. For example, this one into a quad. Now, the next tool, drag tree element, I think it's really cool. I will show you this one here. What you do is you click on a tria and you drag it, and the tree element is moved. And for example, what I want to do here is take this element and just drag it away, so it's gone. So let's see here. I click on it and I drag it up, and it's gone. I do it again. Click on it and it's gone. Okay, we have two tools left. The split collapse edge tool. By left-clicking, you can split an edge, and by right-clicking, you collapse an edge. I will, just as an example, split this edge. I left-click, and this edge is now divided into two edges. And by right-clicking, the edge is collapsed. And by collapsing, for example, this edge and this edge, I can fix the elements a bit. Now, the last tool is the smooth tool. This tool you use to select several elements if you want at the same time, and HyperMesh uses an iterative optimization technique to move all the nodes of the selected elements to make them more smooth and more, that they look better. And I select, for example, like these elements, and I hit smooth. And what they did now was that the nodes were moved, and now the mesh has a better quality. I can show you again. I think this drag tria element is really cool. First, I combined some trias here and drag, for example, here. I can just drag it away. I think it's really awesome. And this here, this merged trias, if you have this selected, and you drag a tria and you hit another tria, they will be merged into a quad. So here we have one tria here and another tria here, and by dragging this one here, it's combined into a quad. Okay, that was all the 10 tools. I also mentioned this element patching, which is a way to quickly toggle through the elements you want to check. So now in my model I have 4 elements left that I need to check. And when I hit start here, HyperMesh will zoom in to these elements and make it much easier for me to fix those. So when I hit start, one of the bad elements are zoomed into, and I can choose whichever tool I want. I use element optimize here, and I just click on it. It's fixed. I go to the next patch. I fix it. The next patch, fix it. Next patch and fix it. The next. Okay, now all my elements are fixed, and we have a quality index that is close to 0. Okay, that was the quality index tools. Yes, the live demo here. The next tool I want to show is the comparison tool. And the comparison tool is also new in HyperMesh 13. The purpose of this tool is to perform a model-based CAD to CAD or CAD to FE or FE to FE comparison between two models or two selections of entities. This is very useful when you, for example, want to compare, or when you want to find geometrical differences between two models. What you first have to do is, under the Generate tab, is to define some options that will be used in the comparison. First, you have to select how the two entities are located to each other, if they are on the same location, or if they are maybe translated or rotated along a vector next to each other. HyperMesh can also automatically calculate the transformation matrix, and then you just have to select the auto option under the location. Then you select the source and the target entities. You have to define a tolerance value. There's some more options to include shell thickness and some options to improve the accuracy of the comparison. However, with a result of a bit slower comparison. And the next tab is the Review tab, which here you have the results broken down into 4 categories: unmatched, intersected, overlapped, and matched. And the entities will be displayed in a color according to these 4 categories, and you can check and uncheck them to make them visible or not. And how these match types are calculated depends if you're comparing a CAD to CAD or a CAD to FE or an FE to FE. Furthermore, you have the results tab, which it displays some area-based qualitative results for the comparison. That means that the area as a percentage for the source and the target entities of each match is displayed here. And you have the option to export some comparison data and as well as the result. And the last tab you find is the sets tab, which you use to create entity sets from the generated comparison. And then you will have entity sets in your HyperMesh session. Okay, also this tool I will show you live. I will open a new model. Okay, what we have here is 2 components. First, one component with a surface and some holes in it. And I want to compare this component with a different version of, they are pretty similar, but here we have a mesh and it differs a little bit. And I want to use the comparison tool to find out these differences. The comparison tool we find under Mesh, Check Elements Comparison, or under Geometry, Check Surfaces Comparison. Now, these 2 components are located at the same position, so I choose same side. As a source entity, I want to choose my surface. Surface all displayed. And as a target entity, I want to use the elements of the second component. Elements displayed. I use a tolerance value here, and in this example I will leave the rest of the options unused here. I hit run, and I'm brought to the review tab, and you can also see that the display here is changed. So now I will hide the surface component, and first of all you will see that we have the review type, either comparison, which displays the elements according to these 4 categories, or I have also an option to choose the distance, and I have distance and apply. The element will be colored according to how far away the distance from the source, and you will have a legend showing this also. Okay, if I go back to comparison, the source and the target types are displayed with different colors, and I have to hit apply here. Then you see again this view, and for example here the mesh is missing the hole which the surface had, and therefore these elements are marked as unmatched. And next we have the results tab, which shows you some statistics over the comparison results. And we have also the sets tab, where you can create entity sets. So if I hit create now, we will see that in my HyperMesh here we have 5 entities created. And if I close my tool, and for example I want to have a look on the target, all the unmatched entities for the target, right click and isolate this, and we see which elements were unmatched. Okay, that was the comparison tool. The last tool that we will have a look at is the model checker browser. A problem I'm sure many of you have encountered is that after you set up a model for an analysis, you launch the simulation only to discover that it errors out because of some modeling errors. and often it can require several iterations with launching the simulation, identifying the error, fix it before you have a good model. Now, the model checker browser in HyperMesh can drastically increase the probability that you will get a problem-free solver run already on the first trial. You find it under Tools, Model Checker, and depending on which user profile you're using, you will have the option to either obstruct. We also support Radios, Nastran, Elsteina, Abacus, and ANSYS. So what is it doing then? Yeah, it performs different checks, which are divided into three categories: error, warning, and info. All the checks under the error category means that these errors will lead to that the solver won't run. It will error out. And these are of course the most critical ones to identify. The warning checks are possible problems that won't stop the solver, but it still might be a modeling mistake and you want to check on that. And the info check gives some general model info. What you have to do is hit the run button here, and all the checks are checked. And in this example, we see that 3 error checks have failed. And now the problematic entities can either be automatically or manually corrected depending on which check that has failed. For example, this error was a free rigid with some connectivity issues, and how to fix this, you simply right-click and click on auto correction, and this will delete this rigid element. Or some of the checks auto correction is not possible, then you can instead choose manual correction, which then will bring you to the corresponding panel that you need to use to correct the entity. So all this means that the user cannot only quickly identify the problem in the model, you can also very easily act and correct which problems you have. The checks that are used are defined in a configuration file. The default configuration file you can modify it, or you can create your own customized configuration file where you can then add custom checks. And I will not go into detail of this, but all information you need you can find in the HyperMesh reference guide. Okay, I will also do a live demo of the model checker browser. Okay, what we have here is car body in white. It's not that important, but what we want to do is check if there are any errors in this model. And if I go to Tools, Model Checker, and for this case we are using the Obstruct user profile, the Model Checker windows is opened, and here you can see all the 3 different check categories, so info, warning, and error. Here is the configuration file, the default one is now used, and when I hit run, all these checks are performed, and we can see that we have 3 checks that are failed. First of all, we have a property which is missing a material. The ID of the property is displayed here, but you can also simply right-click and isolate this. Then you will see this component in the view here, and the property which is missing a material, you cannot simply auto fix this. You have to use a manual correction, and when I hit manual correction, the corresponding panel is open. So this is the property panel, and I want to update the property for this component. It is missing a material, so for this case it should have this material, and when I hit update, this component now has a material, and then when I rerun the check, we see that, yeah, the check is not longer failed. It has material. Next error is an element. It's a rigid element with some connectivity issues. First, I will isolate this to find it, and I will have a look on the elements that are attached to it. Okay, so let's see here where we have it here. What we see here is this rigid here should be deleted. We don't need it. And to do this, I right-click on the check here, I apply autocorrection, and when I do this, this element, this rigid, will be deleted. It's gone, and since this was an auto correction, the model checker is automatically updated. Now the last error is we have 3 duplicate elements. I first isolate them, and now when I display the rest of the elements in this component, of course, since they are duplicate, when I fix them, we will not notice a difference, but we will know that the elements are fixed. So to fix this, I simply right-click, I hit autocorrection, and the 3 duplicate elements will be deleted. And now all the checks that are available in the model checker are passed, and yeah, that was the model checker tool. Okay, so today we have had a look at how we can use some HyperMesh functionalities to identify elements with bad quality and how to correct them. We have also had a look at the comparison tool to identify geometrical differences between 2 models. And now in the end, we also use the model checker browser to identify and correct model errors. I thank you for your attention. I hope the webinar has been interesting and useful for you.